Hey guys, Christoffel symbols for the radial geodesic and in general, and their meaning. Let's do it. So the radial Christoffel symbols are this: RTT equals RS, R minus RS over 2R cubed. You notice that's positive. What does that mean? That means as time, right? They don't look like this, right? Because as this is like the flat. And maybe blue I'll do or purple I'll do the curved one. If I have a time basis vector projected in the time direction, meaning I move it here, it increases in the r direction, which means it curves up like this. That difference is the Christoffel symbol. So my t hat gets bent in the r direction, and it'll keep getting bent. Now notice as r goes to infinity, right, this goes to zero, which means that that curvature gets less and less and eventually approaches flat space-time up here. So the point is the time axis is curved up. What does that mean? It means that there's this compulsion, this organic motion through time. So if something starts out here, and this is my like, R equals RS, notice that my lines of constant radius are now bent upward. Right? That's what a time axis is, right? Constant R, which means the compulsion through time goes like this. So a straight line now, right? If I'm just moving through time normally, makes me move through space, makes you fall through space. This creates gravity. Let that trip you out. That the time axis is actually moving upward, creating this motion or flow of space downward. Boom. That's how we interpret that. Pause that, rewind that. I'm just going to keep moving on. RRR is this. It's negative RS over 2R R minus RS. What does this physically mean? This means that if I project the R in the R direction, say I have a spherical mass M here, and I take my R hat vector here and I project it in the R direction, it will shrink as I go farther out, which interprets it that it actually stretches as I go closer. So space stretches close to a mass. That's kind of cool, which means distances literally get farther apart. So that's kind of cool. So both of these create the gravitational effect, which ends up matching Newton's gravity perfectly, which is like a surprise that it actually matches Newton's gravity perfectly. That other video, I showed that in from just the metric. If you solve for the radial geodesic, you get this. Let me just be 1,000% sure that I know what I'm doing right now. Radial geodesic. That's R double dot equals. Let me make sure I got this down. I feel like I could figure it out, but I just want to make sure I know what I'm doing. Oh yeah, that makes tons of sense. So remember the geodesic equation is, xi double dot equals this, where that I matches in the upper. So we need coordinates that bend in that direction. That's what causes those geodesics. JK, what is it? Xij dot, or sorry, xj dot xk dot, right? And negative. That's a dot, that's an I, that's a dot, that's an I. Probably could write that clearer, but I think we got it. And of course, that's an Einstein sum, right? Which means we need to do what? We need to have all of the ones that are RTT. We need to know R theta theta, R phi phi, Oh wait, I forgot R, right? So if we just have radial motion, right? And if we do orbits, we're going to do these. These ends up being what are called centrifugal terms. Centrifugal forces we can go over. That's pretty easy. It's just like if you're in the accelerated reference frame, it seems like there's a force pushing outward that you have to accelerate against to go inward. So your acceleration will actually be that. Another way to look at that is that's your mv squared over r term classically. We can derive that from Newton and show how the equivalent here is, what is it? Negative r minus rs, I believe it is. Yep, that's what this term is. And I think this one's the same thing. And we can show how those match. Let's ignore them for now and just do these two. So we get t dot squared minus r dot squared. Great. This one we showed is like gravity from the t axis moving to r. This is r stretching. This value is positive. This value is negative. So be careful. This value is positive. This value is negative, which means this ends up fighting gravity. R stretching slows R double dot. Why? Well, if you have farther to go as you get closer to the black hole, right? More space means slower. That's too obvious, right? If my space keeps increasing, right, then it's going to be a slower velocity, right? If this distance, right, keeps growing, and my time isn't changing, my time is changing in a different way, right? It's not stretching also, right? Then it's going to be slowed down. I hope that conceptually makes sense, actually. And it turns out this plus this actually will equal this. If you plug in everything here, and I'll leave it as an exercise for you to do, and you plug in that energy, or sorry, from the Lagrangian, that T dot equals E over 1 minus RS over R times C squared. And RS is 2 GM over C squared, which you plug in at the end. You plug that in at the end, and you plug this in into here, right? And you plug this in and you plug this in, right? You plug it all in, you will get that this is negative gm over r squared. I think you need one more thing. You need to plug in something for r dot squared. That was addressed in the metric video. From the metric, right? You get, right, that you can solve for r dot, and you get that r dot equals something here. Where are you? R dot equals, I could probably figure it out on my own, but I've written it down for my convenience, and I've lost that convenience. Somewhere I've lost that convenience. I kind of want to do it again. What is it? R dot's gonna be from this. It's gonna be remember C squared equals 1 minus RS over R T dot squared minus, oh, there's a C squared there, minus R dot squared over 1 minus RS over R. So if you divide everything by square squared, this is the metric. Remember, this is the Schwarzschild metric with no angular terms. Then you should get that R dot equals, if I add that over, divide by everything, you can solve for in terms of T dot squared. Plug that in there. I tried to do it in my head. My brain just just got destroyed. If you do that, plug that in there, you simplify that, you'll get this. Or you can just trust that it works because we derived it the more simple way from the metric. So the point is you can get to two different places in two different, sorry, the same place from two different methods. But anyway, here's the conceptual, right? Christoffel symbol meaning. That's it. Keep it simple. I hope that made sense, right? We're literally interpreting the Christoffel symbols, plug them into the geodesic. We see we get the same thing if we use r dot squared from the metric. I hope that made sense. Plug that in, plug in t dot squared from energy, plug that in, and we end up getting same thing, right? It ends up working. It ends up working out. So we can just, it ends up, everything just ends up canceling, which is kind of marvelous. I feel like I'm leaving something out that I'm not remembering from that. And I'm sorry about that. Sorry, my notes aren't clear in front of me. I thought I had them clear, but they're not. Either way, all good. Um, Point is, we can go through that later if you want. I just didn't think that was that important. I think the conceptual, what those two terms meant was the most important. Sweet. We can do the algebra later if you really want, or not.